Welcome to today's Explainer. We're diving into something that's literally the blueprint of our digital lives. We are going to unpack database architecture and database management systems, or DBMS. Think of database architecture as the master plan for all modern data systems. It dictates exactly how a system is built from the ground up and how we as users actually interact with that data. It's a fascinating puzzle, so let's get right to it.
Here's our roadmap for today. We'll kick things off by defining database architecture, then trace its evolution, from the simple Tier 1 setup to the Tier 2 client-server shift, right up to Tier 3, the modern standard. After that, we'll peek under the hood at the 3 schema architecture and wrap up with how all of this powers the real world.
Section 1. What is database architecture? The foundation of data management.
So, what exactly is it? At its core, database architecture is the grand design that defines the structure, the inner workings, and the interaction methods of a database system. You know, it isn't just about where a file sits on a hard drive. It's the overarching game plan. It acts as the ultimate traffic cop, making sure data flows exactly where it needs to go, exactly when it needs to be there.
Simply put, this architecture exists to seamlessly manage the constant chatter between 3 main players: the users who actually need the data, the applications those users are topping away on, and the database itself where the information lives. Every single architectural model we're going to look at today, it's really just a different, increasingly clever way of connecting those 3 dots.
Section 2. Tier 1. The simple setup. Everything in one place.
Let's start at the very beginning with one-tier architecture. In this setup, the user application and the database both live right there on the exact same system. There are no networks, no complex middlemen, it's just you directly interacting with the data. If you've ever fired up a basic local database tool, say Microsoft Access on your laptop, you've used one tier. You open the file, the app loads, and boom, the data is right there on your local drive.
Now, why don't we run the whole internet this way? Well, one tier definitely has its perks. It's incredibly simple to set up, and since everything is local, it is lightning fast for small applications. But here's the catch. Having a user poke around directly on the machine hosting the actual database is a massive security risk. Plus, it's practically impossible to scale. You literally cannot have thousands of people logging into one local laptop. That severe lack of security and scale meant we desperately needed an upgrade.
Which brings us to Section 3, Tier 2, the client-server shift, splitting the workload.
Enter two-tier architecture, where the tech world decided to literally split the workload in half. Now we've got 2 distinct players, a client application and a separate database server. In this model, the client fires a request over a network directly to the database server, which crunches the numbers and sends the result back. Think of a clunky desktop app in an office that connects to a big centralized SQL server humming away in a back room somewhere.
This shift brought some huge wins. Security took a big step forward because users weren't sitting directly on the database machine anymore, and it was still pretty easy to develop for. But, as with all tech, fixing one problem just exposed another. This time, massive performance bottlenecks. If you had a ton of users simultaneously throwing complex queries at the database server, the whole system would choke. The server would just get completely overwhelmed by the traffic.
So, we needed another evolution. Section 4, Tier 3, the modern standard. The architecture powering the web. This is where 3-tier architecture steps in, adding a brilliant new layer to the mix. Let's trace the workflow. First, you have the presentation layer. That's just the user interface you see on your screen. Second, we drop in the application layer. This is the new middleman, the application server, built specifically to chew through all the complex business logic. Finally, we have the database layer, strictly focused on storing and managing data. So now you click a button on the interface. The application layer does the heavy lifting, and only then does it quietly tap the database to fetch or save what's needed.
This whole separation of concerns is an absolute game changer. It's the gold standard, universally used today for heavy hitters like banking apps, e-commerce giants, and social media platforms. Why? The advantages are just staggering. Because users never directly touch the database, security is rock solid. Since the application server handles the logic, performance shoots through the roof. And scalability? If you get a sudden spike in traffic, you just spin up more application servers. Plus, keeping the interface, the logic, and the data in their own separate boxes makes maintaining the whole shebang incredibly easy.
Now let's switch gears a bit. Section 5, the 3 schema architecture, the internal blueprint.
So far, we've talked about networks, but internally, a DBMS relies on a specific inside-out framework called the 3 schema architecture. Picture it in 3 levels. At the very top, you have the external level. This is simply what the user sees, completely hiding all the messy code. Drop down a level, and you hit the conceptual level, which maps out the overall structure. Think tables, relationships, the pure logic of the data itself. And down at the very bottom is the internal level. This is the nitty-gritty physical storage detail, literally how the data is magnetically written onto the hardware disks.
You might be thinking, why chop it up internally like this? Well, this 3-schema structure is the secret sauce for 3 massive benefits. Number 1 is data abstraction. You don't need to understand how a solid-state drive works just to check your bank balance, right? Number 2 is enhanced security, since we can tightly lock down what that top external level is allowed to access. And number 3 is incredible flexibility. You can literally swap out a physical hard drive down at the internal level without ever having to rewrite the conceptual logic or break the external user interface.
Let's bring it all home. Section 6. Real-world applications. Architecture in action.
Once you wrap your head around database architecture, you realize it's the invisible engine running almost everything we do. Those complex, highly secure 3-tier setups we unpacked, they are exactly what power global banking systems, making sure your digital transactions are both instant and bulletproof. They're the backbone of hospital management systems, where split-second access to accurate patient data literally saves lives. Whether you're checking out your online shopping cart or a university is processing thousands of student grades, it's these core architectural principles working flawlessly behind the scenes.
So, what is the ultimate takeaway from our journey today? The relentless evolution from a clunky local 1-tier setup to a sophisticated 3-tier framework wasn't an accident. We did it because proper database architecture is absolutely critical. It drastically tightens system security. It significantly boosts overall performance by intelligently dividing the labor. It provides the massive scalability our modern web demands, and honestly, it just makes managing these behemoth systems infinitely easier for the developers behind the screens.